Hello, reality explorers, and welcome to the channel. Take a moment and look around you. Look at your hands, the screen you're watching this on, the room you're in. It all feels solid, real, undeniably. But what if I told you that everything you perceive, the vastness of space, the warmth of the sun, the very fabric of existence, might be nothing more than a fantastically complex projection? What if our entire three-dimensional universe is, in fact, an elaborate hologram? This isn't a thought experiment from a philosophy class or the plot of a sci-fi blockbuster anymore. This is the holographic universe theory, a revolutionary scientific concept that is gaining serious traction among some of the world's most brilliant physicists. It suggests that our reality, with all its depth and complexity, is an illusion, projected from information encoded on a distant two-dimensional surface. So, how can this possibly be true? Let's start with a simple hologram, like the one on your credit card. It's a flat 2D surface, but when you shine a light on it, a three-dimensional image appears. The information for that entire 3D image is stored on the 2D film. The holographic principle scales this idea up to a cosmic level. It proposes that a mathematical description of our universe doesn't need 3 dimensions of space. All the data required to create the illusion of our 3D world, including you, me, and every galaxy, could be fully contained on a boundary surface, a cosmic horizon at the very edge of the observable universe. Think of it like a cosmic DVD. The disc itself is flat, two-dimensional, but it contains all the information needed to project a sprawling, interactive 3D movie with sound, characters, and a plot. We are the characters living inside that movie, completely convinced of its reality, unaware that we are fundamentally just information being read from a distant disc. This idea forces us to reconsider what real even means. Is a video game character not real to itself within the confines of its digital world? It follows a set of physical laws, the game's code, and interacts with its environment. From our perspective outside the game, we know it's just pixels on a 2D screen. The holographic principle suggests we might be in a similar situation. Our laws of physics, like gravity and electromagnetism, might just be the game code of our projection. The feeling of touching a solid object? That's not two objects truly making contact. It's the repulsion of their electromagnetic fields and interaction of information. The universe in this view is less about physical stuff and more about pure organized information. Every particle, every star, every interaction is a pixel of reality, or more accurately, a voxel, a volumetric pixel in this grand cosmic projection. The implications are staggering. If our reality is a projection, then concepts we take for granted, like location and distance, become strangely fluid. Two particles that appear to be billions of light years apart in our 3D space might, on the underlying 2D surface, be right next to each other. This could explain some of the most baffling mysteries in physics, which we'll get into shortly. This theory didn't just appear out of thin air. It emerged from the absolute frontiers of science, from the study of the most extreme objects in the cosmos, black holes. It was the attempt to solve a profound paradox about what happens to information that falls into a black hole that led physicists like Jarrett 't Hooft and Leonard Susskind down this mind-bending rabbit hole. They realized that the universe might be playing by a set of rules far stranger and more elegant than we ever imagined. So, prepare to question everything. The journey we're about to take will challenge your perception of existence itself, as we peel back the layers of our perceived reality to glimpse the scientific clues that suggest we might all be living in the ultimate illusion. So, what evidence could possibly support an idea as radical as the holographic universe? The clues don't come from one single discovery, but from the convergence of several bizarre and counterintuitive findings at the cutting edge of theoretical physics. The first and most powerful piece of evidence comes from the enigmatic nature of black holes. In the 1970s, Stephen Hawking discovered that black holes aren't truly black. They slowly radiate energy and evaporate over immense timescales. This led to a monumental problem, the black hole information paradox. According to the laws of quantum mechanics, information can never be destroyed. It can be rearranged, but the total amount of information in the universe must be conserved. However, if a black hole swallows something, say an encyclopedia, and then completely evaporates, where does the information contained within that encyclopedia go? It seems to be wiped from existence, a direct violation of one of physics' most sacred laws. This is where the holographic principle made its grand entrance. Physicists Gerard Tufte and Leonard Susskind proposed a stunning solution. They argued that the information is not lost. Instead, all the information about every single thing that has ever fallen into the black hole is perfectly preserved, encoded on the two-dimensional surface of its event horizon, the point of no return. Think of the event horizon as a cosmic computer screen. As a 3D object, like a star, falls in, its information gets smeared across this 2D boundary. The amount of information a black hole can store, its entropy, turns out to be proportional to the area of its event horizon, not its 3D. This was a shocking revelation. In our everyday experience, the information capacity of a space is proportional to its volume. Your hard drive stores more data if it's bigger, if it has more volume. But black holes break this rule. Their information content is a 2D quantity. This led to a profound question. If the physics of a 3D object like a black hole can be fully described by a 2D surface, could this principle apply to the entire universe? The second major clue comes from the famously bizarre world of quantum mechanics, specifically the phenomenon of quantum entanglement. Albert Einstein famously called it spooky action at a distance. When two particles are entangled, they become linked in a way that defies classical intuition. If you measure a property of one particle, you instantly know the corresponding property of its partner, no matter how far apart they are, even if they're on opposite sides of the galaxy. Information seems to travel between them faster than the speed of light, which should be impossible. The holographic principle offers a potential explanation. If our 3D reality is a projection, then the distance between the two entangled particles might be an illusion. On the underlying 2D surface where the information of the universe is encoded, these two particles might actually be right next to each other. Their instantaneous connection isn't spooky action at a distance. It's two adjacent bits of information influencing each other on a cosmic hard drive. Finally, there's growing evidence that our universe might be fundamentally digital or granular. Just as a digital photo is made of millions of tiny pixels, some theories suggest that space-time itself is not smooth and continuous, but is made of indivisible fundamental units at the tiniest of scales, the Planck length. Experiments at facilities like Fermilab have been searching for evidence of this holographic noise, a sort of fundamental jitter in space-time that would be expected if our 3D world is a blurry projection of a sharper 2D reality. While not yet definitively confirmed, these investigations show how seriously this idea is being tested. When you combine the 2D information storage of black holes, the non-local connections of quantum entanglement, and the possibility of a pixelated space-time, they all converge on a single unsettling picture. A universe where the third dimension may be an emergent property, a grand illusion painted from a more fundamental, flatter reality. Our solid, voluminous world could be nothing more than a complex shadow play, and we are merely actors within it, unaware of the light source casting our forms. So what do you think our reality truly is? Let us know in the comments below. Subscribe for more cosmic mysteries, and we'll see you in the next one.